Hello everyone and welcome back to another Universe Sandbox 2 video, and today, as you can see, there has been a new update. So this is update 25 now, the I like my heat tidal, or maybe I like my tidal heat. I don't know if they've made a typo there or something, but yeah, this is update 25 now. So you may remember the video I did about a week ago where I explored the experimental build. Well, now the full version is released. You can get it just by opening Steam, and it should update for you. So yeah, if you've got the game, definitely make sure to go ahead and check this out. But yeah, there is now the obviously the new features are now in the main game. So the replace object that we checked out, we'll be checking it out again. As we can see as well, major surface simulation, performance improvements, which is good. Hopefully they fix the bugs with Earth, which I'm definitely going to be checking out in this video. And also temperature and atmosphere rewrite. So tidal heating, temperature calculations have received a major rewrite. This includes significant improvements to vapor flow and overall object energy absorption and radiation. You can see these properties in action in our new energy and heating guides and showcasing the new simulation. So we'll be checking that out. Okay, that's good. And then the hot swappable object. So the replace object button has been added to the properties panel. This will allow you to swap any object in the simulation, like I showed in the other video the other day. But before we get started on that as well, guys, before we get into this, I'd like to go over the highlights. I've got the patch notes up on the internet here as well. So yeah, the game is now officially called Universe Sandbox. They have removed the 2 or the squared, however you want to call it. The little 2 that is gone. The game is just Universe Sandbox now. So yeah, that's everything there. But yeah, so if we just open it here, just Universe Sandbox. It's been like that for a while, but it's now official. Nothing is Universe Sandbox 2 or squared anymore. It's all just Universe Sandbox. And I believe the original Universe Sandbox is called like Universe Sandbox Legacy or something now. So yeah, there is that as well. But yeah, this is just Universe Sandbox. So I have to like change all my titles of my videos now. But yeah, so before we get started though, so since they've gotten rid of the 2, they have also changed, or there's also they've migrated all of the data over. So basically what that means is all of the files, so my objects, my simulations, my screenshots, those files have all been changed to Universe Sandbox now instead of Universe Sandbox 2. So that's why I lost all of my objects. When I went to the new version and then I went back, the old game didn't recognize my Universe Sandbox files. And then they were all deleted because, yeah, they've gone from Universe Sandbox 2 files to Universe Sandbox files. So when you bring the new files into the old versions, the old version of the game doesn't know what to do with it, I believe is the way it works. So it deleted all of my custom objects. So that's why I lost everything, which was a real shame. But I've got them all backed up now. So yeah, I backed all of these guys up before I entered the update. So all of my screenshots, my simulations, they've all been backed up now to the most recent I literally backed them up about an hour ago. So yeah, they're all backed up now. So if I have any other issues, I can just restore them all. But yeah, luckily I've still got most of my stuff there. But yeah, so all of the files now are Universe Sandbox files, not Universe Sandbox 2 files. So yeah, be careful if you're going to go back to an old version. Make sure to back up all your files first, otherwise you will lose everything like I did. So yeah, be very careful with that. But yeah, now that's all out the way. So yeah, the highlights of the updates. So learn about energy flow properties. That's what we're going to be checking out. There's also that's the new simulation. Okay, so new simulation, Supernova now have directional heating to impacted objects. Added directional light to lighting options. Oh yeah, I didn't notice this the other day. But yeah, when I did the experimental build, I noticed it right after or right when I was making the thumbnail for the video. But now a new lighting option. So if you click directional light, it does this. So it's basically like a simulation when there's no star. So say I removed the sun. Actually, no, never mind. But yeah, so realistic's obviously realistic like normal. But directional light always has the light of the planet in the same direction. So if we let Earth go round like this, so now the sun is the other way, but the light of the planet is still facing off into that direction. That's basically what directional light does. So it's kind of similar to studio mode, but studio mode moves with the camera, and obviously flashlight as well, which is there. So flashlight's not the bottom option anymore, but that's what that does. So even if there's stars in the simulation, it doesn't get affected by those, which is going to be very useful for thumbnails, I have to say. So that's a very nice feature. That's good for me. Anyway, that's a really cool feature. So I like that. Nice little change there. So yeah, now moving on. So improvements, tidal heating calculations more accurate, improved lighting for ice and city lights. That will be really cool. So we're going to be checking out some city light objects. So let's go ahead and do that. So obviously Earth we were just at. Let's check it again. So apparently there's some change with the city lights. So here we go, this is what it looks like, and ice as well, so that should be interesting on some objects. But yeah, there's the city lights. Let's try and spawn in an object that already has city lights. Do I even have any? I think, yeah, this planet, Bespin here, this definitely has city lights, or it should do. I don't know why it's like this. I think it may be broken, so that's a shame. Do I have any? Let's try Pascal. I think that should have city lights. I think it. Okay, so that seems a bit glitched, unless that's ice. One of these must have city lights, surely. Let's see here. This one got city lights? No? Come on, I want to get a regular city lights. We've got the Earth texture there, but we need one with the regular lights as well. What about this one? No? Damn, that's really annoying, actually. I don't think I've got any... I'm not sure if I've got any objects saved with it. Oh, no. Trantor, I know this one for a fact had city lights. Okay, that's quite annoying. I keep double-clicking and closing it. Yeah, so also... You can double-click and it like opens and hides the interface here, which is quite cool. Okay, this one definitely had city lights on it. Is there any? No? Ah, dang it. Okay, so I don't think I'll be able to show that then, unfortunately. But there must be a slight change to the regular city lights there. So, yeah, I'll have to see if we can quickly... I'll give it another try. So if I know this object for a fact is supposed to have city lights. Maybe if I just add a bit of water to it. Click play. Is it going to warm up? No, we've got obviously the ice there, so that's had a change. Because, yeah, the ice did look very pixelated. I know that for a fact. So hopefully they've changed that a bit as well. I'm trying to... Any city lights? Come on. So it's got water on it. There's plenty of water there. Let's just try and get the atmosphere up. Maybe then it will reactivate the lights. Because I know the planets always have to be like a certain temperature and stuff. Let's just see if we can get it to a nice, comfortable temperature. So that's in orbit of the sun. It's getting some very hot temperatures there. So it's 25 degrees. So right now there should be lights. Oh, yeah, there is. Yes, there they are. Okay, cool. So it is tinted, but the light texture will still appear the same. So let's just remove all the water. So there we go. So the water's removed. Okay, so this is what the city light should look like now. So let's just try and get... Okay, there's a nice bunch of them there. Okay, so let's just get a good look. So if we just zoom in, I'm not seeing too much difference. They still look fairly the same to me. But yeah, there they are. So apparently they've had a slight tweak as well. So yeah, there we go there. So now moving on. Okay, so yeah, tidal heating, that's all that. Obviously, we've got the stuff changed with the lighting and ice. Okay, so that's cool. Revise the initial temperatures for solar system planets better matching with known values and our stable... Okay, that's cool. So simulated stable temperature ranges. So the solar system planets have had a slight change. Rename user save object folder from bodies to objects to be more consistent with our labeling. Okay, so that's also why I lost my objects, is because it renamed the folder. It renamed the folder. So maybe that, and then it converted all of the files across. But when I opened it in the old game, it couldn't read the folder, and then there you go, it deleted it. So yeah. Be very, very careful. I'll say it again, be very careful if you were going to go back to an old version now, because it will delete all of your objects. So yeah, make sure you back them up, because it's changed a lot of things in this update. Okay, so switch accuracy, turn in profile to accurate. Okay, simulation audio volume has been set to 0 by default. Developers note, we feel that the simulation sound effects collisions are not up to our standards. For now, we're leaving them in but muting by default. Okay, because I remember they've been a bit buggy in the past. There's also some fixes with temperature. Realistic lighting mode was shown on objects despite no stars present in the simulation. Fix an issue of missing spacecraft in the 1980 and 81 Voyager simulations. Okay, so just a bunch more stuff. Okay, so here's the new content now. So we've got 2 new guides, so we're going to get straight into those. So let's actually get some stuff up. So most of it's just been me talking so far. Okay, so there should be 2 new guides. So here they are. So we've got Flyby of Ash. Oh no, Tidally Locked Habitable Moon. Okay, so it's this one. This is the new one. Okay, here we go. So... Right, so a star's habitable zone indicates the distance at which an object has a surface temperature by allowing liquid water to exist, but that only takes into consideration heat coming from the star. Other types of heating, such as tidal heating, can raise the surface temperature on an object too. So this will be an example here. In this simulation, 2 identically sized objects, each twice the size of Earth, orbit on either side of the star. Both are outside the habitable zone of the star, and one of the objects is a frozen planet. You may need to zoom out to see the cold planet. The other object is a gas giant, which gravity creates tidal forces to heat the moon enough that its surface is habitable. So here we go. So these are too far away from the star, but the heat from the gas giant warms this this guy up here. So tidally heated moons. Here we go. Right, so there we go. So I remember tidally locked objects were not always consistent, so maybe that's all been fixed now. So surface. Okay, so obviously that's all relatively looking the same. But is there a way to see if it's getting it from heating rates? Yeah. So all these new options, I'm not sure they were there before. So I think there's a few new options in here. So yeah, there we go. Nothing new in there. Just seeing all the menus. That looks the same to me. Okay, so I want to say the surface. I want to say some of these are new options here. I'm not entirely sure. So yeah, If I'm wrong, please someone let me know. But yeah, I don't remember it. I don't remember all of these options being here. But yeah, as you can see, tidal power, you can see it's getting energy from that. So stellar power, so atmosphere power, super. See, you get all of the ways that you can create heat. They are now. It now shows what is making the heat. So that's quite a cool feature. I like that. So yeah, there it is. If you want to access that. So yeah, there we go. So if we zoom out here, this was the cold planet. So that's the planet all by itself. It's at the same distance. It doesn't have tidal heating because it has no gas giant. But since this one does have a gas giant to warm it up, it's getting warmed up to 18 degrees there. So that's a nice little simulation just to show you how it works there. So yeah, there we go. Okay, so 2 new guides. Okay, so there's a new tutorial as well. Okay, so let's go to tutorials. Where are we up here? So tutorials? How do I even find them? I can't remember. There's experiments. Not often I go in these, I have to say. Oh no, tutorials is in a different. Where are we? Tutorials. It's on one of these. I forgot. It's on a different. There we go, guys. Yeah, I'm blind. Okay, so energy and heating. So this is a new guide. So let's see what they've added here. Okay, so Universe Sandbox can now simulate heating and cooling across the surface of a planet. But the details of this surface simulation can be hard to see when the planet is moving quickly through space. Like the Earth in the simulation. Okay, so there goes. So Universe Sandbox. Oh, I love how the camera moves like that. Oh, it's going too fast, man. I didn't even catch what that said. The surface view mode gives you. Yep, so we know that. So open view. Oh, surface. Oh, so there's now a button. Okay, cool. I like that. So now when we zoom in on Earth, we have a clear view of the planet's surface, so I can drag around as well, even though it's rotating rapidly in space. Oh, that's awesome. Okay, so Universe Sandbox calculates the temperatures of each planet by simulation the flow of energy in and off the planet's surface. You can now see all the details of this surface flow at a glance in the Surface tab. Okay, so maybe it was that stuff I discovered. So maybe it is new then. So surface. So average surface temperature, yeah, we know that. So the average surface temperature is useful for seeing the change in temperature of the entire surface. Try lowering the average surface temperature to 0 degrees. Okay, so put that to 0 and it will freeze up a bit, yeah. The Earth is covered in snow at this cold temperature, but the simulation runs the surface will warm back up due to where it is in the solar system, due to the energy flow through Earth's surface, melting the snow again. The energy flow section shows how fast Earth is absorbing energy. So yeah, I'm pretty sure this area is new. This energy flow, I'm pretty sure that is new. Okay, so yeah, they go, and I'm sure these new options here, I'm sure these are new. They've got to be. I'm so sure they are. Right. So yeah, there we go. Okay, so properties like average albedo. So that's how affect how fast Earth absorbs light. So increase the albedo. So that if we make it reflect all the light, that's going to get cold very quick. So the high albedo means the Earth is reflecting the sunlight rather than absorbing it. So the surface will begin to cool again. Eventually, the oceans will eventually freeze over. Yeah. So if it's reflecting all the light it receives, none of that heat is going to the surface of the planet. So that means the planet's going to completely freeze, no matter how close it is to the star, pretty much. So yeah, there we go. Continue on the Energy and Heating Science Guide to learn about Universe Sandbox energy flow simulation. Or if you're ready to start exploring on your own, go to Home and then close Guide. Okay, so that's going to take us to the new... So this is the science simulation. You're using the guide. Okay, oh cool. So it actually lets you know up there. So if we just go to Open here. So we're in the science of science. Where's the science one? Is it experiments? No? Yeah, I don't go in these menus much, I have to say. I don't know. I don't even know how we access this simulation, but luckily we're in it right now. So yeah, there we go. Right, so let's take a close look at how Universe Sandbox simulations the heating and cooling the planets. Okay, so we want to select Earth, open it up. Okay, so it's cool how they give you all these guides and stuff. Because obviously I played the game for a long time. I do know roughly how most of the things work already. But yeah, it's cool to have a guide now to sort of show you how everything works. All these new options. Okay, so what's making the temperature change over time? Look at the flow of energy. Okay, so there we go. So is it the graph it wants us to look at? Well, there's the graph anyway. So next. Okay, so yeah, it wants us to open this new menu. Okay, so there's the new menu there. So as we can see, Earth is getting energy from stellar power, atmosphere power, tidal power. Because remember, the moon is the thing. Or is the moon even in the simulation actually? Okay, there's no moon. Okay, so don't forget the moon. So I'm guessing that the tidal power is actually all just from the sun itself. So the only thing that Earth is got by, or it's producing itself, would probably be the atmosphere power then. But yeah, absorption rate represents the power absorbed by Earth and various sources like nearby stars. Energy radiation rate represents the power radiated by Earth into space. So there we go, so 196. The more energy, the hotter the Earth is, the more energy it radiates away, okay? Nature likes a balance. Earth will always be trying to reach a temperature where the energy moving in is equal to the energy moving out. This balance is represented by the... okay, so, yeah, this one here. I'm not even going to try pronouncing that because I know I just scrapped the word. But yeah, we have got this new value here. So this is balanced. Okay. So always be trying to reach a temperature where the energy moves. Okay, this balance. So that's the balance, that temperature there. Okay, that's pretty cool. So why isn't the average surface temperature always the same as the other one? Okay, it takes time and energy for material to change temperature, which is determined by the surface heat capacity. The lower the heat capacity, the faster the average surface temperature will change as the Earth absorbs and radiates away. Change the surface heat capacity and watch how heating rate increases. Okay, so this was something we tried looking at in the This was something we tried looking at in the experimental build, but I didn't sort of get how it works. So now there's an actual tutorial. Let's increase this value to say 5,000. So there we go. Change the heat and watch how the heating rate changes. Okay. So let's see how that does it. Oh, let's just times by 2 actually. So it's a 10,000. So is that gonna make a difference up here? We can see it looks like the overall temperature is dropping a bit. Up the top here, the white area, that value has gone from 22 to 21. It looks like to be decreasing a bit. So the heating rate we can see is also changing. Okay. So what are the possible sources of energy in the simulation? Okay, so select the icon next to energy absorption rates to see the specific energy. Okay, so that's what we got there. Currently the Earth is absorbing energy from 3 sources. So yeah, there we go. So we've got light from the sun, atmosphere power, and then tidal power. So, okay, so tidal power represents friction within Earth caused by gravity. So I'm assuming the sun is still sort of involved in there as well with the gravity, since it's the biggest thing around. What about the next 2 values? Supernova power and supernova drag power. They're both 0 right now because there isn't a supernova, but we can change that. Okay, so we're going to blow up the sun, I'm assuming. Okay, so explode. And then, so let's make the sun supernova. Oh, yes, okay, so let's see. Okay, so let's see these values go absolutely crazy. So here we go, supernova power. So this is going to really incinerate the Earth. Okay, so watch the supernova power rise as Earth absorbs the energy from the supernova's light. Note that the solar power has gone to 0 as there is no more stars in the simulation. Yep, there we go. We can see that supernova that's going to increase quick, and we can see the surface grid at the top here as well to see how that works. But the supernova power is increasing, so let's see how high that goes. So note the solar power. Yep, so there we go. Okay, oh, it's moving by itself. Right, supernova drag power represents the friction caused by passing supernova clouds. As these clouds pass by Earth, you will see this power increase. Okay, so as soon as that starts to increase, the Earth is in the supernova cloud. Rightio, okay, cool. So, we can see the temperature on Earth's changing as well due to the no sun anymore. Right, so there we go. Over time, the small amount of energy from the passing clouds will decrease, but the side of the Earth facing the supernova will continue to heat thanks to the huge amount of power that supernova emits. So it kind of works like a tidally lock-in then, but I'm guessing the planet should still rotate. But yeah, so the side facing the nova, so this side, that's going to be a lot hotter than the nighttime side. So where Africa and then South America are right now, those two, for example, they're going to be a lot colder than this area where sort of like China, Japan, Australia is, mainly the Pacific Ocean here. That's going to be the hottest point. As we can see, it's going into the 600s to 700s, increasing more into the thousands now. And yeah, there you go. So the supernova is scorching this side of Earth, but the other side is getting colder, going into minus 11 as the coldest point now. So over time, the small amount of energy from the passing clouds will decrease. Okay, so we already read that. Try experimenting with different simulations, planets, and properties to see how the energy flow in and out of a planet is affected by stars, gravity, collisions, and atmospheres. Okay, I want to try this with you, Ice-Gussie. I want to see how crazy that gets. But look how scorched Earth is now. 8,000 degrees. I wonder if the Earth will survive now. Because supernovas used to just obliterate all of the inner planets. So I wonder... do novas not destroy Earth anymore? Would Earth get destroyed? I think in theory it should still, I'm guessing, but who knows. So finish. So I want to see if this gets completely incinerated. So it's white hot now, look at that. So 15,000 degrees and increasing, so that is scorching. That is absolutely scorching. And even the nighttime zone, that is now increasing up into the 30s. So if we just pause it. So we go to flashlight. So that even this is going to start to evaporate, even though it's the nighttime side. The planet is still rotating, remember? So some of that is going to... We can see the heat is spreading as the planet rotates. So once it does a full rotation, the whole thing is going to get scorched. And then this area is going to go into the nighttime. But I'm guessing that isn't going to cool down nonetheless. But yeah, look how scorched the front of that is. Oh my god. So let's just rotate it a little quicker. So here we go. So every time it rotates into the daylight, as soon as it touches the daylight, or the supernova light, I guess, it just completely scorches it. But yeah, okay, so it still gets destroyed by supernovas. Okay. Okay, and I'm guessing that's going to obliterate all of the inner planets. So let's just see if... I'm guessing, I think Uranus as well. Where's it? So Uranus usually gets... Oh my god, what is going on there? But yeah, Uranus usually gets destroyed by novas as well. It's the only gas giant usually to get killed by them. But what is going on here? Okay, yeah, I think we've found a glitch. I think gas giants get... Oh, and it's rocky on this side. Oh yeah, because, yeah, whenever a supernova hits Uranus and Neptune, it usually removes all of the hydrogen off it. But yeah, Uranus still gets destroyed by novas, and it's usually the only one. Oh, Neptune's been destroyed. Pluto's still around. Oh, did it destroy all the gas giants? Oh, it destroyed everything. Okay, so that's new. It didn't used to do that. Supernovas never used to destroy Jupiter and Saturn and Neptune. Those three used to be the only objects that survived novas, but it has destroyed absolutely everything. That's the whole solar system gone. I'm guessing that's a little more realistic, to be honest. I mean, with a supernova, I mean, that has some big firepower there. So I'm guessing, yeah, that's quite a, well, I think that's quite cool, actually, that, yeah, the novas now obliterate everything. Nothing survives. You can see the asteroid belt's all that's left there, but yeah, because they don't get affected by the heat. That's what, minus 273 here, but yeah, that's okay. That's cool to know. So even the gas giants, Jupiter, Saturn, Neptune, even they get destroyed now, because they used to be the only three objects that survived. But yeah, that's crazy. I'm gonna detonate one in my custom simulation. I want to see if it will destroy Planet 9, because Planet 9 is obviously a lot further. I'm gonna put Planet 9 at its furthest distance, so we can actually have a little fun with this. So I'm going to put Planet 9, so we're going to put it all the way out here. So we're going to put it at its furthest point. I guess we can do it with the Goblin and Sedna as well. I want to see if those guys can survive the Nova at this distance. And then we've got Far Out over there as a comparison as well. But obviously, all of these are going to get destroyed. But I want to see if Planet 9 at its far, far distance will survive. So it's 674 AU away. Is that big enough to survive these new supernovas? Let's find out. So we're going to, yeah, click play. Obviously, you're going to go to Tools, Explode, get that sun. There we go. So let's see what it does. Will Planet 9 be affected? So we'll put it on Trails as well. There we go. So there we go. Right, so close that all off. Right, so we can see Saturn here. Look how hot it is. I mean, 500,000 degrees. That's going to get obliterated. We see it's losing mass. Gone. Completely obliterated. So Neptune as well. No hope there. Orcus. So they're all gone. So the next target would be Sedna. That's the closest object right now. Is Sedna far enough away to escape? Let's find out. So once the supernova cloud, obviously... Oh, so it's already getting hot now. It's nowhere near the nova. Look how far away it is. The nova... There's no way the nova clouds have reached it yet. We can check with these new surface options. So let's go to... Okay, so we're energy flow, yes. So Supernova Power. So yeah, we've got no drag power yet. So it's not in the cloud yet. But it's already receiving supernova power from this distance. Okay, so the Goblin... The Goblin is... So how's the Goblin doing? So the Goblin is 200 degrees. Planet 9. Planet 9! So that's getting... Oh, that is really cool how that looks. Let's go ahead and zoom in on that. That looks awesome. Look how that's rotated. Oh, that is so cool. Okay, so... Oh, Planet 9 is getting burnt out. Oh, no. So, there we go. So let's just slow it down. So, there we go. So, it's Planet 9's rotating. And as we see, as it rotates, it is losing material. But that looks really awesome up there with it. Look how the heat is just flying around the planet like that. That is so cool. So here, oh my god, look at this. This is happening in about 11 hours. Let's slow it down a bit. So this is what's actually appearing. So as we can see, as it goes to the night time, it does cool down a bit. But as we get closer and closer to that nova, that heat is eventually going to spread around. But we can see right here, there is a part of Planet 9 which still is a lot cooler than the rest at minus 110 degrees. In the coldest areas, but obviously as soon as it gets to the side facing the supernova, that's where it's going to start getting very, very spicy. And as we can see, that's getting very, very hot. And yeah, how hot is it getting now? So we're going into the 2,000 degree area, but is it far enough away to survive is the question. So yeah, Planet 9, I'm guessing Sedna's not going to make it. I don't think it will. I think it's too close. And then we've got the Goblin over here, because as soon as it starts to get drag from the clouds, I'm guessing that's going to be where... I'm guessing that's how it's going to get hurt. So let's let it go a little bit more. So the Nova is eventually going to hit Sedna and Planet 9, but will they survive at their furthest points? So, oh, Planet 9's gone! Oh, no, never mind. No, it's there. Oh, it's lost mass. It's lost 0.01 mass of Earth. It's gone. The Goblin over here... That's very calm. It's cooling down, the Goblin. Sedna. So it looks like they may have survived. Is it getting drag now? Yes. Yeah, no. It's getting a tiny bit of drag. I mean, a very low amount. Planet 9. So how you doing? No drag at Planet 9 yet either. So let's let it just shoot out now. So there we go. Oh my gosh. What is this? What is going on here? all the white areas, that's very, very funny looking. But how's the planet doing itself? So, looks to have cooled down. So, it looks like at its furthest point, Planet 9 can survive. I mean, it lost a tiny bit of mass there, but it's still in one piece. It's only lost a very small little bit. The Goblin, I'm guessing, is alright. And then Sedna. Okay, so they're alright there. But what about at their closest distances? Let's see if it survives at its closest distance. So, let's go ahead and then explode the sun right now. So as we can see, Planet 9, Sedna, the Goblin, they're all a lot closer than they normally are. So let's just go ahead and close that. We're going to move to the Goblin. I'm going to make the Goblin close. So let's just go ahead and open that. And then we're going to go ahead and move it. Okay, so the Goblin is now at its closest point. Planet 9's pretty much in its closest point. And then Sedna, we'll put you at your closest point. But if Far Out got destroyed, and its Far Out is further than Sedna at the moment, I'm not expecting Sedna to survive. But maybe Planet 9 will be able to hang on at its far distance there. So let's click play, and let's find out. So put it back to Trails. So there we go. So we've got a blue supernova this time. Obviously, these guys aren't going to... There's no chance with any of the normal objects, but let's see. So that's going to explode out. Oh, Planet 9's gone. We've lost Planet 9. The Goblin, you going to survive? I'm not sure. Maybe it's because it's a custom object, it may survive. But Planet 9 is gone. Sedna as well has lost mass. It's tiny now. Okay, so, yeah, if you move them closer, they're getting affected more. But are they going to survive? There's no... Oh, the Goblin's gone, I want to say. No, the Goblin's still in there. I don't know why that's surviving. Maybe because the density was locked. I'm not sure. But I think it's just because they're custom objects. There's sometimes custom objects, their physics work differently. And probably because it's from an old version. But as we can see, even Planet 9, which was the furthest object out. So in theory, these two should have been destroyed. Because Planet 9 was further away and it got destroyed quicker. So yeah, I don't think those two should even be there. But yeah, if you move Planet 9 closer, it's gone. So at its furthest distance, it can survive. Closest distance, no, it's gone. So yeah, pretty interesting experiment there. So hopefully you guys enjoyed that. But yeah, that is really cool. So let's just move on to the rest of the stuff, because I believe there's some more patch notes, but I think we've mainly covered everything. So there's new visuals for the object picker used in the replace object feature. Okay, we can check that out. New icons for advanced property expansions. Added distance to closest star to overview tab for all objects. And then there's just some bug fixes and stuff. But yeah, that is everything. There's also some like... Okay, so there's not anything with that. Okay, so it was just some VR stuff. There's some... They're just mentioning something about it. But yeah, there we go. So then it's just a bunch of fixes. But yeah, there we go. So that pretty much covers everything in the simulation. So I guess the last thing we can do is just try out this the replacement feature, as there's something that's changed there. So how are we doing? So we've got Earth here. We'll just try and replace that. So we can replace it with any of these guys. So here's Earth. Still broken by the looks of it. Yeah, it's still broken. That's quite annoying. But let's see here. So replace object. Okay, so this interface should look different. Okay, so I've clicked it and the game's frozen. Please don't crash. Please don't crash. We don't want to crash. No, please don't crash. Okay, there we go. Okay, so looks fairly similar to the way it did last time, but apparently there's something they changed here. So say we want to put... Oh, what could we put in there? Okay, let's go to a custom objects. Let's put... Oh, we could go with so many here. There's so many to choose from. Let's go with... There we go. Let's go with the largest exoplanet. Replace. Okay, so now that, so HD 100-546b, that is now replaced where Earth was. So click play, and obviously that would cause all the carnage there. But yeah, there you go. So the replacement feature, very, very useful indeed. That is going to be very useful for creating systems and for updating your custom solar systems. If you want to put, say I wanted to change Saturn. Say I modded a new Saturn, I wanted to put that in. Well, I could simply just do this. So replace. I wouldn't have to enter any of the orbit coordinates or anything. I could literally simply just replace it, and then say I went with one of the Gasser objects as my new Saturn. So I want to update my custom solar system, and there we go. I simply all I need to do is do that, and then the Gasser blue is immediately in the same orbit as where Saturn was. So it saves all the time having to put these options in. I don't have to do this anymore. That's going to make things a lot easier. So yeah, I think the replacement feature is definitely one of the highlights of the update, I have to say. So yeah, really, really cool, and yeah, really, really nice job to the developers for adding that, because that is going to be very useful for certain things. So yeah, really, really nice indeed. But yeah, there we go. So that does it for update 25. So I think it's been quite a long video. I don't know how long I've been going for, but yeah, I think this has been a really, really cool update. Wow, half an hour pretty much. Damn. But yeah, I think this update is really, really cool. I like the new supernova effects. I think they're a lot better now that they destroy pretty much everything. I think that's really, really cool. And yeah, the replacement feature, really like that. And also the tutorials. I like how they've sort of taught us how all of the new options work. I really, really like the addition of the temperatures. So yeah, I really like the energy flow options here, where you can see where exactly how an object is getting its energy and stuff. I think that's really, really cool. But yeah, I think those are my sort of top 3 things from that update, I have to say. So yeah, really, really cool stuff to the developers. I doubt they watch these, but yeah, really, really nice job there. And yeah, guys, let me know what you think down below of update 25 in the comments. And yeah, let's see if we can go for 40 likes for the new update today. So update 25, let's see if we can get for 40 likes on this video for that, guys. And also make sure to subscribe. Helps on the journey to 13,000 subscribers now. Make sure to, yeah, click that subscribe button. Yeah, helps on the journey to that. As I noticed, a lot of people watching and not actually subscribed. So yeah, make sure to hit that subscribe button and click the bell if you want to receive notifications and all that stuff. But yeah, with that all the way, guys, that is everything. So yeah, I really, really hope you enjoyed today's video, and yeah, make sure you guys all have a great day. But yeah, that's all out the way, guys, so yeah, make sure you have a great day, and I'll see you in the next video. Goodbye.